Hello, fellow. My name is James Owusu-Appiah, and I believe in innovation and doing things differently. This video has been prepared for you to guide you through some well-known concepts that will aid your studies and preparations towards exam. Due to COVID, we cannot meet in person to discuss, so I hope this video finds you well and helps you achieve excellence. Thank you.
Okay, so welcome back to the part 2 of the micro-P tutorial series. So in this section, what we'll be doing is that we are kind of going to, select the various components that we'll need, arrange them and then create a connection between them. So that's going to be the purpose for this section. So okay, so if you're not seeing the part 1 of this video, please try and check it out, because I did discuss a lot there too. So without much delay, so let's get started. Now, what we need is that, so I'll be using these few reference images so that it can be easy to follow, right? Now these images, okay, we want to see the components that we need. Where are they coming from? So the components will be using, like, why do we need them? So if you see here, looking at the microcontroller here, this is the microprocessor part of it, and then these are the peripherals, right? And then this is the one that we are going with. So let's first get these peripherals in place, right? The ROM and then the RAM. So the ROM is going to be the instruction memory, and the RAM is going to be the data memory. Yeah, so let's get started. So what I'll do is that I'll use this one side, like it'll be such that one side of this page I'm going to use this section here, this side for the peripherals, and then the other section for the microprocessor itself, which is the combination of the control unit and the registers and then the ALU. So let's get those components quickly. So let me start with the peripherals. Let's see the memory first. So we need a RAM. So yeah, let me take my RAM and add it and put it in place. Then we also need a ROM, right? Okay, these are the peripherals, so we'll need these two for now. And also, if you check back here, if you check this thing, we also have the I/O ports now, the input and output port. So I'm not going to add it here now, because for the sake of simplicity. So because it's a little bit involved to kind of work with the I/O port, so I'll leave it out for now. Yeah, so you can read on that yourself. So we'll just put the ROM and the RAM in place here. Now, so with the ROM and the RAM here in place, let's just try and label our components. It's a nice thing to always do, like to label the component that you are using. Yeah, so I will just label this and I'll call it our data memory, which is a ROM over. So that's a data memory, and I will name this the instruction memory. So that's how it's done. So after labeling this thing, now next thing is that, because you see, we will need some register to be able to hold the address, the location where we want to read from memory, right? We'll need a register to hold it temporarily so we can do the reading. So that's why we'll be. So I'll pick this register here. Now, so let me first talk about the size of the memory, the data of the memory as a whole. So the microprocessor will be designed is going to be an 8-bit microprocessor, and even though the memory really doesn't so much has nothing to do with the bit weight of the microprocessor, so, but in this case, because you see this is going to be more specific, you see, and that's because we are using the microcontroller style, something like that. So you see, we the memory we allocate, this is going to be a small memory, right? So yeah, that's why we're using this 8 by 8 RAM. So which is that we have 256 bytes of memory. So our data memory is going to be 256 bytes, right? And the instruction memory too is also going to be 256 bytes. So you could change it anyhow you want it. I mean, you could give any memory that you want. So it all depends on the purpose for which you are designing a microprocessor for. So depending on the purpose, then you will know the amount of memory that you need to allocate to these components. So for now, this memory are fine. This 8 by 8 RAM is cool, and then this 8 by 8 ROM is cool for everything. Yeah. And then, as I said, we'll need a register to kind of store the address that we want to read from, to hold it temporarily. So that's how we need. And because our RAM is 8-bit, power means we'll need an 8-bit register so that we can be able to address all the elements within the, we can be able to address all the memory location. So we can't use a 4-bit register, and that would be wasteful. So the same also apply for the program memory. We also need a register too, so that when we are reading a particular value from a particular location, we can save that location temporarily. So I think this does it for the peripherals. So if you check the diagram here, so you see here these are the peripherals. So this is our RAM, this is our room, as you can see down here, and the IO ports will not be there now. Yeah. So let's go to the microprocessor, part of it, which will be on this side. So let's see the components that we need for those part of it. So we will need a lot of registers here. See, registers, a lot of them will be needed. And then we'll need our control unit later, and then our arithmetic and logic unit as ALU, right? So let's first start with the registers and see all the various registers that we'll need for the microprocessor. Yeah. And these things, like once you have already designed it, you just know the registers that you will need, right? But for the first time, you might be happy, you might not know why we need this or why are we bringing all these things, but then and the next time you try to do this, I'm sure you will be fine with it. So let's get the registers that will be needed now. So let's start with a very one. Yeah, I would say we'll need a program counter, right? And so you might be wondering if whether a counter is a register. Yes, it's true. A counter is actually a register too, but it's just a special purpose register, right? So it's able to increment its content. So that's how a counter is like. And then it does it automatically, with the clock. So, but it's also a register because you can actually store value into it. It has a load input, as you can see here. Okay, so you can see that, right? Value to load into a counter. So yeah, it actually store data. So we'll need a program counter, and the reason, okay, so our program will be stored in memory, right? So at every instant we'll need to know where we are. We need to know where to fetch the next instruction. So that's what the program counter does. It kind of keep track of that for us. So it's like a variable or something. Like to kind of keep track of that. So let me just label it again. It's always good to label your component. And this is going to be so that's a program counter. Just call it PC. You could give it any name that you think it's nice with it. But here I prefer program counter, so PC is cool. You can use that for it. So the program counter is there. Now another register that we'll need is going to be the current instruction register, right? And then the size of the program counter will also depend. You see, so since the memory or the instruction memory it has an address bit width of 8, so which means the program counter should also be 8-bit counter, right? So which means it should be able to count or hold values up to about 256 cc. So that's what determines the program counter with. Now the register also, as I said, the other register will need to be the current instruction register, right? And what this register does is that it holds the current instruction that the control unit is currently executing. So yeah, it kind of hold it, store it. It's a variable that kind of store what the control unit is currently executing the instruction. So that's why it's called the current instruction register. And so I'll just call this CIR for that current instruction register. Now in an actual microprocessor or something like that, you'll see they have a register file, right? Now because actually there are a lot of these registers, even for the instruction or current instructions, like they have a lot of this register. What happened is that you'll see later on. So during execution, the control unit is able to kind of fetch multiple instructions at once and kind of keep it in this register, these tags or registers. And as I said, a microprocessor already has a lot of registers in it. So as a result, it does need some way to be able to keep track of all this, and then to make it easier and efficient. So, but for this thing is basic, so we'll just need one register to store one instruction at a time. That is it. So we have our current instruction register. Then another register that we'll be needing will be the micro instruction counter, right? The micro instruction counter or the step counter. So what it does is that I'll try and say little about it now, but later on I'll explain even more about it in part two, part three of this video. So it kind of like it keep track of the steps, right? So for instance, let's say we have this current instruction we're executing. Now we might require multiple steps to be able to successfully execute this instruction. So what keep track of those steps is the micro instruction counter. That is basically it for now. Yeah, so that's what it does. I will call it a MIC, micro instruction counter. Okay, so this you could give this in any other name that you want it to. So, but this is fine. That MIC is good for me, so I'll use that. And then we'll also need another register. And even though I will not really say much about this register for now, right? It's kind of like not really a register, but it's okay. It's a register actually. But I will not say much about it. The only purpose of putting it here is now is because like it will make things easier now, right? So because initially, if you have this sort of some template and then it just because yeah, it will make things easier for us. So that's why I'm kind of introducing it now. And what it will be doing is that it will kind of it will need some apart from the current instruction and apart from what is the state of the micro instruction counter, we'll need to get other feedback from the system. So this feedback will be stored in what in this feedback register. So I'll call it FB actually FBR feedback register or something. So just for additional inputs right to the system. Let me just call it FB to make things easier. Okay, FBR right. I said FBR is fine. So I'll call it feedback register or something. And later you'll see it will make it easier for you to work with other things. And this particular style is meant to make things easier. So all the approach and style I'm using is doesn't really focus on efficiency. It's more of ease of understanding. Yeah. Hopefully, I hope hoping that it'll be easy that you understand. Now let's see. So apart from all this register, we'll need another register to one other popular register, which is for the accumulator, right? So, and I'm sure you should be aware of what the accumulator does. Okay, so basically it's kind of like somewhere where we store value temporarily. You see, it's a special purpose register actually. So we normally work a lot with the accumulator. We store value there temporarily to kind of take it to other part of the system, right? So, and the control unit actually work a lot with this register, right? The accumulator. Yeah, so we store temporary values there, and you see as you implement the instructions, you will see how we use that. So there is the accumulator, right? So with the accumulator set, and then okay, so for now I think these are the registers that we will need for our microcontroller, but not this, but for our microprocessor. But these are not all the registers. I mean, a lot of as we go on, and then as we add more instructions, we might be adding more registers and things, right? We'll have a lot, but for now, just for the template, this is fine. This is all I'll have there, and it will be up to your task. When you're implementing or adding more instructions to the microprocessor, right? So you will now add registers as you need them, and from whatever research you make. So let's see. Let's still see if we are okay. So with our microprocessor, we have the registers. I mean, say all these registers are in place. Now we have the control unit. Now we are not going to design it now. That'll be the next, in part 3 of this video. So yeah, we will not use the control unit now. Then the ALU to actually, now if you already had an ALU, you could have just put it in place. But for now, I'm not going to. Okay, I think I'm actually not going to integrate the ALU now into the system, right? I'm not going to integrate the ALU into the system. Yeah, so I'm not going to integrate it into the system right now, and I think that'll be I think that is the purpose for this whole exercise as a whole that you are to do. So you will try it and do it yourself, but you see how the approach that I'm using will be very easy to be able to do the integration, right? Yeah. So when we come to the control unit, I'll say more about that. So for now, I think with that, I think it's cool. So the ALU is done, and then the control unit is fine. So which means basically you have all our components. So the next thing that we need to do is how do we connect all these components, together, right? Now,